Welcome back. This is Larry Benko W0QE, and a little less than a month ago, I ordered a NanoVNA. I have several other VNAs that I use regularly, but the NanoVNA was interesting because there was a lot of chatter about how good it was. It was very inexpensive, so I just went ahead and bought one. And the one I bought was the black one as shown in the picture here. Now, before we begin with my observations of the VNA, let's talk a little bit about some of the history. There was an article in QST in November 2006 written by Bob Clune, who ended up taking that design. It was a construction project of sorts, and he took that design and was called the AIM-430, and it was an HF only antenna analyzer. And it basically, I think, was the first one that there was a construction project for. And it was kind of a construction project because it wasn't really a kit or anything. But it was followed up by a review of the product that became a commercial product, which was the AIM-4170 in QST August 2007. And it was compared to a couple other products. And it's been a very good product. It's no longer made. It was discontinued just recently, but it's a great product. And it set the standard for a lot of the junky products like the MFJ 259 that were out there and kind of stepped the game up for a lot of people. Well, a few years later, actually only 1 year later, Thomas Baer DG8SAQ, and that name should be familiar to people who have one of his analyzers. It was a homebrew kit, and it was an article in QEX, and he discussed how to build the circuit and how it worked. The AIM-4170 did the same thing too, but it was only measured S11. And this was a full, well, this is not a full network analyzer, measured S11 and S21. And the article is very good. It's available. You can on the ARRL website. You can find PDF of it, and it's an interesting reading. Also, Paul N2PK had an analyzer. It was a 60 megahertz analyzer. I know there was something written up about it, but I couldn't find it. But nevertheless, if you read particularly Thomas Baer's article, you will figure out exactly how the circuit works. Statistics-wise, I believe when I make measurements, I believe 80% of the time I'm making an impedance measurement. That covers both antennas and components, but by far that's the bulk of the measurements. Next probably would be measuring both S11 and S21, such as for filters and some networks. And finally, just for S21, and the only time I usually do that is if I've got a piece of coax that I want to make sure, if it's an old piece of coax, make sure that the loss hasn't gone up or anything in it. So even though it's a network analyzer, it's used for impedance measurements probably most of the time. And I think I fit in a category that's probably typical of a lot of users. But nevertheless, you don't want to give up the capability to measure the through gain of a circuit. So here's what I bought. And this is a picture of a page I captured about a week or so after I ordered it from Amazon. I've blown it up a little bit. It was made by a company called OrSync, and it was shown in a group of pictures here, but primarily it showed the unit as coming with a battery and with shields. Now, some of the units that are sold without a battery, and I can understand that because there's shipping issues with lithium-ion batteries. This was coming from Amazon, and obviously they didn't have the same requirements as someone else may have, but this is what I bought. It's not what I got, but it's what I bought. Now, what I got was this product, and it was very close. It came in a cardboard box with some little bubble wrap around it. It came in a plastic case. It came with a USB Type A to C connector, and came with two cables that were about 13 inches long, a open short load, and a SMA female-to-female adapter. And here's a picture of it. And it was scratched like crazy on the front here, but this was just a covering for the display, even though it still looked like it had seen some tough days, but there was no scratches in the paint, just on this piece of plastic that covered the display. Anyways, if you put a credit card, line it up right on top of this, you will see it's exactly the same size. So this is the size. This is really tiny. The fact that you can make electronics this small doesn't necessarily mean that that's good. I think it's a little bit too small. It's a little hard to read. Of course, as we get older, our eyesight's not as good anymore, but it doesn't really need to be quite this small, even though you can make it this small. Ignoring that fact that it's tiny, which kind of makes it seem a little bit less useful to me, it nevertheless is kind of it's a very interesting product. Taking the screws out of the front cover and the back cover exposes a naked circuit board with some threaded connections between the on either side of the circuit board. And what we see is we see a microprocessor, we see a DSP, we see an oscillator that's the 2-channel oscillator. I'm not sure what everything is exactly on here from this picture, but we see a 450 milliamp battery. We see the little jog wheel here, an on-off switch and a USB-C connector, 2 SMA connectors. And making some measurements with a dead battery, I turned it on. I let it die overnight. It lasted a few hours before it died, and I left it on all night. When I charge it, you get a 670 milliamp charging current to begin with. That's a little high maybe for a 450 milliamp hour battery. That's charging at greater than a 1C rate. But nevertheless, that's what it charges to. At 30 minutes, it drops to 260 milliamps. And by the time we get to 70 minutes, it goes to 0. And it can be charged forever and ever. This is with the power switch off. With the power switch on, of course, it goes up and never goes to 0. It goes to the residual power that the circuit is drawing, which turns out to be 120 milliamps. I'm getting a little bit ahead of myself here. The switch is a hard switch. If you turn this off, there is no battery draw at all, which is nice. So it's really an on-off switch. It's not a soft on-off switch where every few weeks you need to charge the battery or anything. And the unit draws 120 milliamps when sweeping. When you pause it, the display stops, but coincidentally, it actually still continues to put the RF out. Just like it's scanning, it just doesn't update things, which is a little odd and I think probably really not right. If you pause it, I think the RF ought to go away. But nevertheless, that's what it does. So it's 120 milliamps anytime the power switch is on, and which means you can divide that in there into 450, and you get 3 hours of use on it. And 3 hours of use is quite a bit of time. And it's really kind of, I mean, it's nice. There's enough room here. You could put a bigger battery if you wanted in there, as long as the battery was thin enough. This connector right up here, I believe, is made for a JST connector. They didn't put the connector on it. They soldered the battery leads on here directly. We have some programming leads on the side here that we can use to flash the firmware. We only need to use these two. And that's pretty much it. Here's a closer picture of it with a ruler on the side. And it has a menu system. The menu system, again, this is small. The menu system is small too. These could have been made larger. There's no reason to see the screen while you're trying to press these. I cannot press these reliably with my fingers and not maybe get the next one. It's just too small to do. So I end up pressing them with this small pen, which is got a soft kind of rubber tip on it, which is meant for displays, and it works pretty well. Here's a close-up of the board. The close-up shows now I didn't receive a board that had the brass shields on it. These are formed metal shields. They have tabs several places. They look quite nice. There are 3 of these. This one is soldered on correctly. This one's soldered on correctly. This one has the lip on the top here pulled up and soldered to the top of this can. I don't know why it did that rather than soldered down to the circuit board, but that's how it came. I didn't change anything. Here's the circuit we typically see for the board. It comes from a guy in Japan. He goes by the name of Eddie555. He posts regularly on reflectors and stuff. He designed it. Although, again, this design is very, very similar to the AIM4170 and the DG8 SAQ analyzers in that it has 3 mixers. We get a kind of a cheap receiver with 1 mixer, so we basically don't have to have a broadband detector like the MFJ259 had. We have the oscillator here, the SI 5351, which is a 2-channel output, square wave output, so we can use the harmonics at the higher frequencies. And that's pretty much it. The original design accommodated a SIM card, but it's not put in any of the designs that I've seen. Making some measurements of the RF output into a spectrum analyzer that was set to be peak detect. And I let it run for a while, so I actually saw all the individuals. This was running, my spectrum analyzer was scanning at the same time, and after a little while you get the peak at all the places. It shows 101 points here, which is the typical number of points in a scan. and we see an output level of minus 13 to 14 dBm up to 100 megahertz, and then we see an output that's minus 10 dBm, and then it drops down again. And up here we're using the third harmonic, and it drops down 10 dB for the very simple reason that the output is very rich in harmonics. A fundamental of minus 13.3 at 10 megahertz, 30 megahertz we see about 10 dB reduction. So the third harmonic is 10 dB down, the fifth harmonic is about 15 dB down, and this is very, very close to what a square wave is. A square wave would have no even harmonics, but this obviously has some slight distortion in the duty cycle, so it's not exactly 50-50, so the second harmonic shows also. But nevertheless, this is what it is, and this is typically a common thing to use. However, my other analyzers, all my other analyzers, by the way, have single frequency output. Single frequency output, and this is the output for the AIM 4170. My 2180 has the same output, except it's adjustable between 0 and minus 30 dBm. My large HP analyzer works the same way. It's again a sine wave output. Harmonics being down 10, 20, 30, 40, 46 something dB. The DG8 SAQ article describes how to use the harmonics. Now, I personally think that if you were making an antenna measurement on a broadband antenna with an analyzer that had the harmonics, you might have occasionally some issues where you could have another frequency that would appear and mix with the harmonic, and you would end up with an erroneous measurement. But it doesn't happen very often, and it's a good way to make an analyzer work to a lot higher frequency. So here's what I got. Here we see a close-up of the short. The short's just a pin that's pushed hard into this flat surface, which is the short. The open has no pin. It's just an open burl that contacts the end of the SMA connector. Here's the load. Mine was in a stainless steel, or a nickel-plated SMA male connector. And it comes with this female to female. This female to female is not a 50 ohm through transmission, which is unfortunate. These are real 50 ohm through transmissions. This one is, we'll see in a minute, is not. So I took the end off the 50 ohm load, and we see one resistor in there. It's 49.9 ohms. And we see, when I measured the response of this 50 ohm resistor up through 3 gigahertz, we see some rotation on it. Typical belief, and I found this and other people have found the same thing, that 2 resistors works much better. So I went in here with a pair of diagonal cutters and snapped that resistor off. I cleaned up the center pin, and I put back in 2 100 ohm resistors, which gave me 50 ohms. And look at what you got here. Almost no rotation. You see just a little bit going out here out to 3 gigahertz. So this is much better. So the load they give you is not great. It's not terribly bad. It's just not, it could be improved. Now let's look at that barrel connector. The barrel connector, if you put a soldering iron into the end of it, you melt the insulation. It's made out of Delrin, which has a dielectric constant, not 2.1, but more like 3.3 or 3.4. So the dielectric constant being higher means the impedance of that adapter is less than 50 ohms. And what we see is with the modified load, which was a pretty good match when I connected it directly here. Actually, I connected it to the other sex of this connector. We see a 1.1 to 1 SWR at a gigahertz. And if we look at the other ones, we see the other ones being true 50 ohm quality SMA female to female connectors. We see an SWR of 1.01. So again, I took that adapter and threw it in the trash and used adapters that I already have. I made the comment earlier, and I swiped this picture from a posting that was made to the reflector. And here's a product. I said it was too small. So somebody has already come up with a product called a NanoVNA. It's a significantly larger display. I believe it has the same circuit board inside. It comes with the same set of accessories. It even comes with a right angle connector and a male-to-male connector here, which is nice. It sells for more money. I think it sells for like $120. I think you can get it off AliExpress. But it's a lot larger. And for those of us with eyes that are getting older, this may be a much wiser thing to actually purchase. Now, is it completely compatible with this one? I'm not 100% sure. It probably has some different firmware in it It could have some different firmware in it. If the interface to this larger display was exactly the same as the interface to this display, it wouldn't need to have any different firmware. But it may have. I don't know that. And that's part of the problem you get when you get an open source product where people start to improve upon it. But it's very interesting. So if this one costs, say, $70 with some cables and bits like that, and this one costs $100, and I think it's $116, this is probably a better deal. And this one comes in a little metal case. It's hard to see what it is. It still comes with SMA connectors. These SMA connectors are soldered onto the edge of the circuit board, and as such are somewhat fragile. I also don't like SMA connectors like these kind of loads, because as you screw them in, the center pin turns in the connector and wears these connectors out. And some people say, well, I'll put an adapter on there all the time. I would just as soon have a much more robust connector, especially if I was going to take this thing outside and use it. Here's the software that runs it from the original source. Again, when I turn my unit on, the splash screen I get shows this gen111.taobao.com website. If you go there, it's all in Chinese. And this is the software that came with it. It doesn't come with it. It comes with nothing. But this is software I found. However, there's another guy named Rune Broberg. I believe he's from Denmark, and he has a compatible piece of software called NanoVNA Saver, and it's a lot more interesting to use, which is really nice. It's nice to see that we have these people who are interested in improving the product. Now, the problem with that is as the original design gets forked, the compatibilities between different hardware and different firmware loads, it's a little bit of Russian roulette when you can load stuff and it doesn't work. But nevertheless, this is what we have right now. Kind of to finish this up here, what would I like to see? I've got a lot of VNA experience. I understand the idea to want to have a very inexpensive device that's pretty good. The NanoVNA measures quite nicely. But I wish there was a general up-to-date wiki of some sort. It takes somebody who's willing to maintain it, of course. The signal-noise ratio on the NanoVNA reflector is very, very low. A lot of people who are newbies don't know what's going on. They ask the same questions over and over and over again. It's really difficult to separate the good stuff from the bad stuff. And if you don't do a daily digest, you have an email comes in every 10 minutes, it seems like. There are two users groups. There's a NanoVNA users at groups.io. That's the main one. It's got probably 1,000 messages a week, it seems like. And there's one, this NanoVNA-F, which is the new VNA. It's a little bit larger. And it doesn't have too many at the moment. But nevertheless, this is what you get when you do a public domain design. But it'd be nice to explain the hardware-firmware variants. There are perhaps some other hardware variants other than the one I have, and what compatibility they have with firmware that's produced. The PC software that runs the product is not needed. You can run the product standalone, which is an extremely nice feature. So you run it alone. What I'd like to use the thing for would be take it outside, be able to use it, capture a scan, bring it inside, and then upload it. It doesn't work that way at the moment. But anyways, nevertheless, that's what I'd like to be able to do. What does it need? Larger screen, metal box. The NanoVNA-F has addressed that pretty well. I'd really like to get rid of the SMA connectors and go to some small profile in connectors. There's in connectors who have a base on them that isn't real large. It would make the box a little bit larger. They would be much more rugged. I have a lot of adapters I've made for measuring surface mount components and measuring small leaded components that I would like to use. If I'm going to connect this to some large coax on the end of some, antenna, I kind of want a connector that's I'm not going to feel is going to break off. Plus, I want a connector I get hundreds and hundreds of insertions on, not just a few tens of insertions. Also, it'd be nice to see a microprocessor with more memory. It won't raise the price much. There's discussions about people doing this already. But the number of calibration points is 101 typically. Now, the software in the VNA Saver allows you to do segmented calp, and segmented calibration will allow the number of points to go up. But all my other analyzers will do 2,000 or 3,000 points easily. And sometimes you want to be able to do more points. There's also a limit in some of the firmware that you can only do steps of 100 hertz. That's inadequate for a crystal filter. So again, I think all this stuff will get sorted out, but it may take a little while. I'd like to be able to calibrate and make measurements using averaging. Averaging is an extremely important thing. Now, the new software, again, from Rune, allows you to do averaging, but I don't know, it's averaging done with the PC application. I'd like to see averaging done in the firmware. When I say averaging, I don't mean make a measurement and then average those values. I mean the raw measurement gets averaged. The problem with that is my 4170 does it incorrectly, in my opinion. It makes a measurement. If the measurement turns out to be for an impedance that's has a very, very high reflection coefficient, nearly 1, occasionally you might actually get a reflection coefficient that's greater than 1. It automatically jams that down to 1, so the averaging isn't as accurate as it could be. But if you average the raw data, and it doesn't take much more time to do this, because once you set the frequency for the oscillator, you just take several readings, you average those, and then you do something with it. It's also important to be able to calibrate with averaging too. Calibrate where you take several averages to make the calibration files. I don't think that's done currently in the product. Those things are both easy to do, and they just need somebody to drive that. Increase the on-screen menu size. There's no reason that you have those 6 little boxes on the side of that display. They could occupy a larger piece of the display. So if I'm taking this outside, I could use my fingers to adjust things. It'd optionally be nice to do data interpolation. Most of my analyzers allow data interpolation. If they do that, they may show you a little asterisk and say that the thing is no longer calibrated. I recently did a video that described how you can get in trouble at the end of even a short cable of a foot long at a gigahertz with data interpolation. But you can do data interpolation carefully enough, and I showed a way to do it in that video, where you can get pretty good answers. And the deal is that if you go at this, the frequency step size is such that at, say, 900 megahertz, maybe the frequency step size is 10 megahertz. A 10 megahertz difference in sweep is a huge amount of rotation when you have a piece of coax connected to the output. So you're averaging 2 data points to do interpolation that are far apart. And you get in trouble doing that unless you convert those data points back to reflection coefficient and an angle, and in which case then it's a much more accurate way to do that. Anyways, the ability to make standalone measurements and later load to a PC is something I mentioned up above. That is really nice to do. You can't do that at the moment. The only way I can do it is take the PC outside or take a tablet outside. It'd be nice to be able to just take the unit in a little hardened box, little metal box, make a measurement, say the measurement is done, bring it down to your basement or into your shack or wherever, and then load it onto the PC later. And a better jog wheel, or just remove it. The jog wheel is a little bit, mine is intermittent in some cases some of the time, and it's a little funky. If you use it to increment things, sometimes you get too many steps. Personally, I don't think you need it. You could just get rid of it. And it's kind of a pain in the neck to get it outside of a little metal box anyway. So these are my opinions. You may not agree with me. That's fine. If something like these, like a wiki already exists, please let me know. Leave a comment. I may have missed something that's really valuable. If I have, I hope I haven't. But the device is very, very interesting. It makes pretty accurate measurements. I think it could be made to be more accurate with averaging, and it's a lot of fun to use. And I can see why there's a lot of interest in it, and more people getting interested in these topics. And if they're willing to look at some of the videos I have in the past to show how something like this can integrate with SimSmith, you're never going to get a product that's going to just be the PC end of this, that's going to do the kind of stuff that SimSmith can do. Watch some of them and see what you think. But there's a huge amount of stuff you can learn, and it's stuff that it's really nice to see the community in general having the chance to be able to make measurements that you previously couldn't make. Hopefully you've enjoyed the video. It's been enjoyable. I intend probably to just let the NanoVNA sit for a little while and let things kind of maybe stabilize. If there's anything I've done wrong, anything I've said wrong, anything that you disagree with, anything that I've missed, please let me know. Thanks again.